Okay, so the temperature characterization is very important in your freeze drying formulation and then freeze drying characterization. So yes, understand the maximum allowable temperature permitted during the freezing and drying cycle. That's important. And then select the appropriate size vial and fill volume. So yes, the vials come in different sizes, so you have to select the right size vial and the fill volume, and select the appropriate rubber closure system. We'll talk about the rubber closure system, why they are important, because you have to provide the little channel where vaporized water can escape from your vial. So you have to use a unique rubber closure system for your freeze and dry drop. And then determine appropriate freeze-dry process parameters, such as rate of freezing, need for annealing. So it's not just the primary freezing, secondary freezing, and evacuation. If you have to do the annealing, you need to provide the condition as well, and pressure during your drying. All those things should be characterized. And the sealing method, how you're going to seal your drug after everything is dried inside of a freeze and dry machine. You probably need to lower your plate to seal it up. How do you achieve that is a question. Okay, and do you need to fill your drug with vacuum, or do you need, after vacuuming, do you need to fill your drug to with the nitrogen to stabilize it? Then how are you going to do that? It's another question. Okay. And optimize formulation and process based on stability information both during and after lyo process, drying process, and after storage in dry state. All these things are important. And the basic formulation rule, okay, when you develop your formulation method. Number one is try to use non-reducing disaccharide such as sucrose, trihalose first, instead of lactose, glucose, maltose, which are reducing sugar. Okay, they have capacity to donate electrons and change the structure of your drug molecule. So non-reducing sugar are better. And then use non-ionic surface active agents if you have to, such as polysolvate 20 and 80, rather than ionic surface active agents. And try crystalline bulking agents such as mannitol or glycine, but do not use them alone with the protein. Okay. And then do not use dextran, as they are too bulky to interact with the protein to form amorphous matrix. So these are basic rules in your formulation selection. Packaging consideration. Okay, majority of the lyophilized drugs are contained in a glass vial, okay? And tubing vials with flatter and thinning bottom configuration allow better contact with the shelf and more efficient heat transfer of the shelf to the product. So what that means is during your freezing drying inside of a freeze dryer, okay, the better temperature, the heat transmittance should be done. That's what it means. And then the rubber closure system. So these are the rubber cap that are going onto your vial. See that little opening? Yes, it's a single ventilation opening here. But if you have something like that, it's a double vent configuration. So you need to use one of these to stopper your vial. Okay, so you need to choose the right one. Okay, and the co-solvent. Sometimes you use, besides water, you may need to add a co-solvent such as TBA, which is tertiary butyl alcohol, as a co-solvent. So some antibiotics normally have this formulation. So the co-solvent used in freeze-dry formulation offers some advantages, but residual solvent level in the finished product can be a problem because it may not be dried well. But in this case, generally 0.01 to 0.3% level of TBA is found in crystalline matrix. So it could be a problem, but it may not be a problem. That's what it means. Okay. So these are the assignment questions. You need to find the answers for these and then post them. So number 1, what are dispersed systems? Give an example. So suspension, immersion, microsphere, and nanosphere, all those things, right? And then what are general requirements for suspension products? Remember what those are? You should be able to achieve homogeneous suspension with gentle agitation, things like that. So where are they? We'll talk about those. Here you go. Suspension of particle is accomplished with reasonable agitation. Rapid settling of dispersed particle doesn't happen, and particles can be homogeneously dispersed such that consistent dosage are obtained repeatedly, and the particle do not cake or pack at the bottom of the container over a shelf life period, making it difficult. And then a few more. Suspension manufacturing can be reproducible from one batch to another, and they should be drawn up through a 20 to 35 gauge needle. So these are the general requirements. Okay. And then what are immersions? So immersions are what? Strongly hydrophobic drugs that uses lipid-based vehicle. Those are what immersions are, right? And how liposomes similar or dissimilar to micelles? Difference between liposomes and micelles. Micelles are single lipid-based, vehicle wrapping around your drug. So your drug will be extremely hydrophobic. But liposomes are made with what? Double layer of lipid. So your drug may not be strongly hydrophobic, but it should be protected, or it should be delivered that way, so your liposome can be fused to the membrane, so it can be easily inserted into a cell. Okay, so understand the difference. What are main benefits? What are the main benefits of freeze drying injectable drug product? Okay, first, by removing your water molecules from your drug, you will prevent hydrolysis, so you can have better stability during the shelf life. And then by removing water, overall the weight of your drug will be much less, so there will be less cost in the transportation, and as well as the storage as well. Since it's better protected, you don't have to store your drug under the maybe freezing or refrigerated condition. So there are a lot of benefits. And what is the main role for cryoprotectant during freeze drying of a drug? Cryo, again, is a protectant against denaturation during freezing process, right? And the lyoprotectants are used during the drying process. Okay, so cryoprotectant, normally what do? They substitute water molecules when water molecule is frozen, and they go in there and protect the drug molecule. Okay, so that's that.